We always want to start a force problem with a free body diagram. So we always do force of gravity. It's sitting on a surface, so there's going to be a normal force. No other up and down forces. So these two are balanced since it's not in an elevator accelerating up or down. Being pushed sideways with a 250 Newton force. And then, of course, there is going to be a force of friction, which is what we're trying to figure out. So let's just use, for now, the formula for static friction. That's what this formula for static friction looks like. Problem says that the coefficient of friction is 0.72, and so now we need to put in the normal force. Well, looking at our diagram, we can see that the normal force and the force of gravity are the only two forces in the y direction. And since it's not accelerating up or down, those two forces are balanced with one another. So the normal force really is just equal to the force of gravity, which is mg. So we've got 100 kilograms times 9.8 newtons per kilogram gives us 980 newtons. That's the normal force, 980 newtons. So now when you multiply those two things together, I got my calculator here, so 0.72 times 980 is 705.6 newtons. By the way, coefficient of friction, 0.72, really just means that for whatever these two surfaces are, the force of friction is always 72% of the normal force. That's what 705.6 newtons is, 72% of that normal force. Now, it's tempting to think that you're finished the problem. However, we need to think about what this would mean if this were true. That if the backward friction force really were 705.6 newtons, think about how unbalanced those two forces are. This force is way bigger than that force. So that means you'd walk up to something, push it, and it would actually accelerate backward toward you. So this is not the correct answer to what the actual force of friction is. What it is it's the maximum that static friction can handle under these circumstances. Static friction means that the object is at rest. So the way you really calculate static friction is you draw your free body diagram and you ask yourself, okay, how big does friction need to be to keep this at rest? In other words, to keep it balanced. Well, to keep things balanced, friction needs to be equal to 250 newtons. And so as long as the force necessary to keep things balanced is less than the maximum that it can handle, then this is the force of friction. The correct answer here is that the force of friction is 250 newtons because that's the amount of force required to keep things balanced. And it's less than the maximum that static friction can handle, which means that static friction can handle it. All right, I want to go beyond this question a little bit. Let's say, what happens if suddenly this person decides to push with, 1,000 newtons of force? What's going to be the answer to our question now? Well, under these circumstances, let's ask ourselves, how much force would it take to balance that 1,000 Newton push? Well, it would take 1,000 newtons. But now let's compare that to the maximum that static friction can handle, which is 705.6. This is above the maximum. What that means is this object is going to move. Static friction cannot hold it in place. This object is going to move. So if the object is going to move, suddenly we're not dealing with static friction anymore. We're dealing with kinetic friction. And we need to calculate what kinetic friction is equal to. Now, the only way to do that is if you were given a coefficient for kinetic friction, although I didn't write it here. This really is the coefficient of static friction. Somebody would need to give you the coefficient of kinetic friction. Usually it's less than the static friction coefficient. So let's say it's 0.60. All right, so let's calculate that. So now friction would be 0.6 times 980 newtons. Let's see what that's equal to. 0.6 times 980 is 588. And with kinetic friction, you don't have to think about, balancing or anything like that. When you calculate kinetic friction, that is what the force of friction is. So looking at a free body diagram, we have somebody pushing forward with 1,000 newtons, and friction is pushing back with only 588 newtons. Now, another logical question you might be asked here is, okay, so what's the acceleration of this object? So now we can go to acceleration in the x direction equals net force in the x direction divided by mass. So the forces in the x direction would be a forward 1,000 newtons and a backward 588 newtons, all divided by the mass of this object, which is 100 kilograms. So if we do that on the calculator, just make that negative and add 1,000 to it, divide by 100, and 4.12 is the answer, 4.12 meters per second squared.